Hey guys, I got an email that there was some explanation needed on some of these assignments, so I'm going to run through these, just kind of what you're supposed to do and is expected from each of you. So on this Ionic Lewis structures practice, what you're going to do in this first column is draw the dot diagram for every element. And then in the right column, you're going to draw the ion for that element and arrange it appropriately. And so for this first one is done for you. It's similar to what we did on the notes, but in class on Friday or Monday when I was there, we did K2O. So I'll do that one for everybody. What you're going to need though is your periodic table, because the periodic table will guide you into having exactly what you need. Hang on. Sorry about that. I didn't have my table up. So what you'll need on the periodic table is basically the group numbers, and the charges will guide you on how many dots each one should have. So hydrogen, group 1, make it red. Red's funner. They all have 1 dot because they have 1 valence electron and they lose it. So all those plus ones, that means they would lose 1 dot. So if I was going to draw hydrogen, I'd draw it with 1 dot. Group 2, they all have a 2 plus charge, meaning they lose 2 electrons. So magnesium, I would draw with 2 dots. Groups 3 through 12 vary because a lot of them will make multiple different charges. And so they're all positive. So however many they lose, however many electrons they lose, will be how many dots they get. So here we have iron. You could have iron 3, so it would have 3 different dots. Or you could have iron 2. It would have 2 different dots. And so it just depends. But all those with positives are going to lose 3. And then over here are going to lose however many electrons that is. Group 13, it picks back up. They all have positive 3s. Group 14, they're all going to gain or lose 4. 15 changes to a -3 though. So that means they're going to gain 3 electrons. And so remember that magic number is 8. And so if they're adding 3 electrons to what they have to get to 8, what would they have? They would have 5. So group 15 has 5, 16 has 6, 17 has 7, and 18 has 8. And so if you can remember that, if you want to make a note on your table, then all of that would help you out with this assignment. So let's see if we can erase all that. I want to erase everything. Oh. All right, so going back here, we have K2O. So I'm going to have K and O. So just one of each element over here. The periodic table, potassium is in group 1. And oxygen is in group 16. So 16, 6. Group 1, 1. So going back over here, potassium will have 1 dot. Oxygen will have 6 dots. Sorry, it's a little messy. It's kind of hard to draw on this. And so in this next column, you're going to get your Lewis structure. And so if you refer back to your notes, step 1 was to find the sum of valence electrons. So if I have potassium, they have 1 each, and there's 2 of them. And then oxygen, there's 6 total. So I have 8 is my sum. To determine the charges of each, it's how many electrons they gain or lose. And so potassium is going to lose 1 and become a plus charge. Oxygen will gain 2 total and become a 2 minus, but then it's going to get 2 extra dots. I don't know why that one dot went away. That's weird. And then we'll draw brackets around that and the dots. And so that's how our ions will be. That's according to our steps in the PowerPoint. And so what you've got to do at the end, though, is arrange them plus minus plus minus. And so I'm going to have 2 K's and 1 O. And so my pluses in this case will be surrounding the minus. And so you draw with your brackets and your charge. My potassium, both of them lost 1 electron. And then my oxygen started with 6, gained 2, so it should have 8 electrons. And then the charge tells you how many it gained. And so you'll do this for each of them. Remember that it goes plus, then minus, then plus, then minus, just depending on how many you have. If you have more than 1, though, or more than 2, excuse me, so that's step 6 over here. So step 6 says if there's more than 2, you can use coefficients. So in our notes, when we did Al2O3, we had 2 aluminums and 3 oxygens. So you could draw all 5 of those ions, or you could put it together and use coefficients. So remember, these coefficients tell you how many of each ion there is. And so you could arrange it like that for these, like Be3N2, there's 3 berylliums, 3 calciums in that one. So you can do it however you choose, but that's how you'll do this assignment.